Hi everybody, I'm Peter Weidinger, and today I'm going to talk to you about how to determine the molar mass of the air around you. Now, molar mass of air is usually about 29 grams per mole, but it can vary depending on where you are because the composition of the air can change. More nitrogen, more oxygen, you know. So, the way I want to determine this is through a theoretical model of Graham's effusion. And now we would do this. We would use Graham's effusion law, which states the rate of the rates of effusion through a small hole, like in these vessels here, is proportional to the ratio of the pressures inside the starting vessels times the square root of the inverse of their molar masses. So, if we know the rates of the two and the molar mass of one of them, we can determine the molar mass of the other, air. So what I want to start out with is find the rate of a known gas with a known molar mass composition. So what we would do is we would fill a container at a constant pressure, constant volume. We need to know the molar mass. In this case, I'm going to use water vapor, 18.02 grams per mole, and I'm going to be using 1 mole of it. So we would put it in this container at, I've calculated as 247.75 liters as this box, and a pressure of 1 bar. Now if we let it effuse through a small hole, it's going to take a theoretical 5 minutes. And since this box here is the same volume as this box, we would calculate it to be the volume of the box divided by the time it took. So that would be about 50 liters per minute. So now that we know the rate of this gas, we can figure out the molar mass of the other gas by determining its rate. So what we would do is then add air from around us, this 247.75 liters of air, we would add 1 mole of air to this container at the same volume, same pressure, and we would let it diffuse just as we did the first one. And theoretically, it would take about if it was going to be 29 grams per mole, it would take 6.35 minutes to take, which would correspond to 39 liters per minute. And as you can see, this is consistent with Graham's law of effusion. The ratio of the rates, the rate of this one, 50, over 39, is proportional to because the pressures are the same, they cancel out, it's proportional to the inverse of their molar masses. The molar mass of this should be bigger than the first one, and it is. Molar mass of air is about 29. Molar mass of water vapor is 18. So with that, that's how you determine, or you could theoretically determine, the molar mass of air around you using Graham's law of effusion. Thanks everybody.